I'm Dave Churchill. I'm an assistant professor of computer science at MUN. And believe it or not, we actually do a lot of gaming-related stuff now. And I've been involved in developing the courses for that and doing some of the research there. So this is sort of what we've been doing at MUN that not a lot of people know about presentation. So just quickly, first I'm going to talk about what is artificial intelligence, or AI. A lot of people have a lot of misconceptions about AI, what it can do and what it can't do. It cannot take over us. We don't have to worry about that ever. We're not that good of programmers that anything will ever be able to take over. So motivation for AI in game research, why do we care about that at MUN, and why does the government give us money to do that? Brief overview of what we're actually doing at our lab at MUN, and some of the courses that we have at MUN related to games and AI. So what is artificial intelligence? It's not just the best movie ever made. It's actually a terrible term. Intelligence is intelligence, in my opinion, no matter where it comes from. If something is behaving intelligently, it's not artificial. So it should be called machine intelligence, in my opinion, but we've all come to know and love it as AI, so that's what we use. In my opinion, this is one of the better definitions of AI that I've seen, is that AI is the science of making computers do things that require intelligence when done by humans. It's just vague enough to not really answer the question, but sort of answer the question, because what intelligence is its own hour-long presentation. So it's kind of better to answer what can AI actually do right now. If you say what it can do, then that's better than just a definition. One of the things that a lot of people, including myself, trying to navigate around downtown, know that AI can do is planning and scheduling. So if you've ever used something like Google Maps or Apple Maps, which may have taken you into the harbor trying to get here, AI is actually really good at this sort of problem and has been for a very long time. So this is how to get from the Avalon Mall to Signal Hill using Google Maps. This is the sort of thing that I actually do and have been doing for a while in my research, is this sort of search and planning type of AI. More recently, there's been a lot of autonomous control, so self-driving cars. Tesla is going to start rolling out its self-driving car, Uber, ride-sharing, Save the World program later this year, which should be really interesting. But yeah, self-driving cars are already a thing, and they're already better drivers than humans. So that's what AI can do already. Also, lots of image and pattern recognition. Turns out whenever you mail a letter since like the 1980s, AI is recognizing the digits and sending it to the right place. So it's been around for a long time. And now we have facial recognition systems as well, which have been super popular by corrupt governments and organizations for recognizing people, which are also way better than humans at this task. Slightly better use of AI has been in healthcare recently. AI is already better than the world's best doctors at identifying tumors in brain scan images, like several digits higher percentage-wise. Also, robotic surgery is becoming a big thing. And so AI in the healthcare sector, I believe if you want to invest some money in stocks somewhere, that might be a good place to put it, because it's going to completely revolutionize how healthcare is going to be done in the coming decades. Robotics is huge. This is Boston Dynamics doing their best to create Skynet over here by torturing their robots. And this is some nanotechnology over here on the left, using very, very small robots to in swarms in order to create intelligent behavior. Robots also do musical composition. So this is actually a band. They're not composing the music here, but they're playing it. But you'd be surprised how good AI is at making music, like actually composing music. They've done studies where humans can't tell the difference between like background music in video games that's been composed by AI or humans. Also, the artists, watch out, they're coming for your jobs too. It's really good. It's kind of crazy. Over here on the right is this thing called style transfer, where you can give it an animation and a reference image, and it will redo the animation in the style of that image. So you can give it like a Van Gogh or something like that, and it'll just redo all your animation in the style of Van Gogh, and it's really, really good. And over here is Google's really creepy Deep Dream stuff that they did. Also, language processing and translation. On my phone right now, I can take a picture of another language and it will just display me the English translated version. It's amazing. I used it when I was in Japan and it worked. It already works. But the thing that I'm really interested in is in game playing. So on the left here, we have the game of Go, and on the right, we have the game of Starcraft. And when I made this talk a couple of years ago, humans were still better at both of these things than AI were. So spoiler alert, AI is way better than humans at Go now, and almost as good as humans in Starcraft. Still not quite as good as the world's best humans. So you've probably heard of a lot of different subfields of artificial intelligence. So we have things like machine learning, natural language processing, speech recognition and generation, expert systems, planning and scheduling, robotics, vision. All of these things are AI. So if anyone tells you that AI is just this one thing, maybe it's just robotics, it's not true. It's a whole bunch of different things. And my research kind of falls in these three areas, which is planning, scheduling, optimization, robotics, and a little bit of machine learning. I am not a machine learning expert, but it's so good, it's depressingly good. Like in the last 7 years, machine learning has gotten so good at things that you just have to use it now. It's like being a carpenter without using a hammer, right? You have to use it. So machine learning is everyone's in that now. So the Industrial Revolution created machines to do our heavy lifting. The AI revolution will create machines to do our heavy thinking. There's a lot of bleak forecasts that AI might take like 60% of human jobs in the next 50 years. So now we have to decide, okay, what do we do when 60% of the population is unemployed? All these kind of things, but it's not all bad. Trust me, there's really cool stuff that AI can do, such as benefit local industry. There's lots of video game companies, simulation companies in Newfoundland and in St. John's that use simulations and robotics, and AI can help all of these companies, as we saw before in Randy's presentation. Verafin is now trying to get into machine learning as well to try and detect the bad guys, and so AI could help them as well. Also things, this really cool project that I saw a few years back where Environment Canada was trying to save a lot of pollution and money and gas and emissions by more efficiently routing trucks in the logging industry, for example, right? So not only can AI help save a bit of money or automate some processes, but actually could help save the environment, which would be pretty nice if it's not too late already. HQPs, so in the funding industries, they like to say, the funding agencies, they love HQP, which are high quality personnel. And AI programmers are in super high demand right now in a lot of companies. I've had a number of companies in St. John's sort of knock on my door and say, Dave, we need AI, but we don't know why. So please tell us your students' names and their grades, and we want to give them jobs. There's lots of jobs right out there right now for AI programmers and video game programmers as well. I've found that AI also helps motivate students to learn. I walked into class one day and started talking about video game AI, and people actually put their phones down. It was incredible. I could teach to something other than the back of an iPhone. That was really cool. So currently I have 6 students working directly with me. I have 5 master students in computer science. One of Lucas is here, so one of them showed up. 1 undergrad student working with me this summer who will become a master's student in September. And 5 of these people are actually local Newfoundland students. And if you're familiar with the computer science department at MUN, this is sort of unheard of that people actually stay here to do their master's. So that's awesome. It's really cool. I've somehow convinced people to stay in Newfoundland for their master's degree. So, AI research and development, how does it actually happen from our side of things? Well, what we first do is we either identify a problem that we really want to solve, or we identify some methods or an area that we really want to work in. So that's the first step, is identify something that you want to do. Then you review the literature of existing techniques. Hey, has this problem already been solved? That's something people don't often do. They reinvent a lot of wheels, especially in video game programming, right? So we want to do our due diligence and see what's out there, and hey, if this problem hasn't been solved yet, then maybe we can give it a go. So then we try and develop some new technique, right? Maybe this technique is general and it applies to a bunch of different areas, which would be awesome, or maybe it's really specialized and solves one problem really well. Then we actually test these techniques against the current state-of-the-art techniques under specific controlled circumstances. So this is kind of basic science, right? We come up with a new technique and we test it somehow against other systems that currently exist. And then we apply the technique to the problem if it's better than the previous technique. But this introduces a really interesting problem, which is how do we actually test AI, right? So what is artificial intelligence? It's something that's supposed to behave intelligently. And so how do we measure intelligence? Measuring intelligence is a really hard problem. Like IQ tests mean almost nothing, right? Like you can be extremely intelligent, but do very poorly at these specific tests. So how do we measure that? Well, we play games. That's what AI researchers do, is they play games. Because for thousands of years, people have been playing games, and games tend to measure intelligence. Intelligence may be in a very small subset of the world, but games, you have to be intelligent in order to win at a game. So for example, up here in the top left, we have Kasparov playing against Deep Blue in chess. Chess is a purely strategic game, right? You have several minutes to make a move, so it's not like you know, like a soccer game where you have to kick a ball before the time runs out, or you're racing against someone else. It's purely intelligence. You move these pieces and you win or lose the game. Up here in the top right is Lee Sedol playing against AlphaGo when he lost the World Championship to a machine a couple of years ago. Here is a stock image of a robot with a deck of cards, and this was a Deep Stack. It was a University of Alberta researchers created a program that are better than the world's best humans at heads-up, no-limit Texas Hold'em poker. So another problem that's kind of been solved by AI. And down here is IBM's Watson beating the world's best Jeopardy players, but that was actually kind of... Did anyone watch that? The Watson match? Wasn't that stupid? It could click the thing instantly. Like, come on. Give it a delay or something. I still don't believe it really. It didn't beat Ken Jennings. He knew all the answers. All right, I'm a little salty. So AI, games and simulation. Computer games are simulations, right? There is literally no difference between a simulator and a video game, other than video games are often more fantasy-based than simulators. Simulators are trying to recreate some physical phenomenon, usually. So games can simulate the real world, and therefore solutions to game AI can help translate into the real world, right? Someone recently, I can't remember the name of the researcher, but they took Grand Theft Auto 5, plugged it into OpenAI Gym, which is a reinforcement learning framework, learned how to drive a car through the streets of Grand Theft Auto 5, then put that algorithm into a real car, and it drove around. It's like, it just worked. And now, you wouldn't put that directly onto the streets, of course, not enough training data, but it actually did work. There's no ethics required for games. If you do any academic research, sometimes, you know, if I would say, okay, I'm going to go hire a bunch of people to do some experiment or ask them questions or put them in a test chamber, I would have to get through a lot of paperwork because I'm basically going to be, you know, maybe hurting these people or telling them bad things. And so games don't require ethics. Robots don't have feelings yet. So they're very cheap, right? Simulations are cheap. Simulations are cheaper than robotics, and robotics are cheaper than people. And so that's kind of the hierarchy of cheapness. And we want things that can simulate the real world really well, don't hurt anybody, and are super cheap. That's like the trifecta of academic research. And so games and simulations really, really fit into that. They're also really easy to visualize, and they're intuitive for people, so they understand what the game is, what the objective of the game is. They're also really fun to program and play, and they motivate students to learn, I think. The courses that I've taught that have involved games and AI in some way have had by far the highest class engagement of all the courses that I've taught. So it's really great to see humans pay attention in class. So, for the past 40 years or so, or 50 years, I think the first chess program was written in the 1950s sometime. So game AI has been around for a long time. And so here, you know, we have chess, we have checkers, we have Go, we have Starcraft, and Starcraft is really the only game left that AI is not better than humans. Every traditional board game, a lot of the card games, and a lot of video games as well, AI is currently way, way better at the game than humans are. Even so, who knows what Dota is? People have heard of Dota? Okay. So OpenAI's OpenAI 5 recently beat the world champion team at Dota 2 in Dota 2. I'm not sure how restrictive that match was, but it's very impressive nonetheless. In Starcraft, OpenAI, or DeepMind, Google's DeepMind, has a system called AlphaStar, which recently beat human professional players, but by far not, like, nowhere close to the world's best humans, but still human professionals. So it's catching up even in Starcraft, which a lot of people thought wasn't going to happen for like 5 or 10 years from now, at least. So it's amazing how quickly everything has caught up and how good AI has gotten. But not only can we apply game AI solutions to the real world, right? It's not all about curing cancer, but that's very important. But video games themselves are important, right? They are currently bigger than the music and movie industries combined, right? In terms of employment and revenue. So even if all you do is make video games better, that is a huge industrial benefit, right? So there's something like $100 billion in video game sales in the US, I think in North America, in last year. So it's pretty gigantic industry. In Canada, it's a huge industry as well. It added over $3 billion to the Canadian GDP in 2015. That was a 31% increase in 2 years, and these are old numbers. I wish I had the newer numbers, but it's only gotten bigger. The Pan-Canadian Artificial Intelligence Strategy, the federal government allocated $125 million for AI research in Canada. Now, granted, like Edmonton, Montreal, and Toronto got all of that money, but still, the government is starting to realize, okay, AI is actually a big thing. Quebec allocated over $100 million over 5 years for AI. The Montreal Institute for Learning Algorithms got almost $5 million in funding from Alphabet, which is Google's parent company. So there's a lot of funding going into this. And luckily, I was able to get some funding from NSERC and ACOA and InnovateNL to do some research at Memorial. So the benefits of game AI, well, in games, you can have a better in-game AI. You can have more intelligent NPCs. You can have a better single player. Who's ever done an escort mission in a video game, right? Wouldn't you really love better AI for those? But not only that, this is something that I'm trying to push recently as well, is that as a game designer, even if Google came to you and said, here's the world's best AI, sometimes you don't really want to use that AI, even if it is really good, because video games are about user experiences in the end. And if you're just getting your butt kicked all the time, that's not always the best experience. And so even if you have really intelligent AI, you oftentimes don't want to use that in the game. And so what I'm trying to push is that we can actually use AI offline to help create things like more balanced video games or reduce human testing, right? You don't need 1,000 players trying to get out of bounds in Mario to test your game before you ship it. Maybe just tell an AI, hey, your goal is to get out of bounds, right? And then it will find 1,000 different ways to break your game for you. And surprisingly, there's very few people doing this right now. They still have swarms of game testers. And then you can apply this to any game and generalize it, and it'll be great. Okay. So myself and some people in our research group, we have been looking at real-time strategy video games specifically. So why do we care about real-time strategy video games? Just to explain what they are, if no one knows what an RTS is, they're kind of like a war-like simulation. You know, you play this commander where you have units, single-player games or multiplayer games, and we focus on Starcraft, which is the best-selling RTS game of all time. Millions and millions of copies sold. It's been played professionally since 2000, actually 1999, depending how you look at it. It's got a growing research community, and the Starcraft AI scene is gigantic. So I started working in Starcraft AI at the University of Alberta in 2010, and at that time I think there were like 8 people working on it. And 10 years later, Facebook AI, Google DeepMind, Baidu, Tencent, Microsoft, OpenAI, there's at least 10 different major companies working on Starcraft AI. Unfortunately, because of Google's recent success, a lot of those companies have kind of moved on to other things. But it's been a really huge research domain among academics and industry people for the past 10 years, more recently in the past 3 years. We've had international Starcraft AI competitions since 2010. I've run one of them since 2011, and now it's actually held at MUN every September. So every September, people from like a dozen different countries, last year we had 29 submissions, I think, submit to this international Starcraft competition, and yeah, we run it at MUN in our lab, so it's pretty cool. But why do we care about this? Real-time strategy games have a number of properties which make them really, really interesting. They're real-time, simultaneous move, so both players act at the same time. It's non-deterministic, which means there are random elements, imperfect information, so you don't get to see the entire map, so you have to infer things about hidden information about the opponent. You have multi-unit control, unlike in chess or checkers where you're just moving one thing. You might be moving dozens of units around in a game like this. It has an unknown game engine, so you kind of have to make guesses about how the pathfinding works, this sort of thing. And the action and state spaces are huge. There's billions of different combinations of things you could do at any given turn, and these are all really, really hard things for AI systems to do. So it turns out the properties of real-time strategy game systems are also the properties of a lot of problems in robotics and in the real world, right? And so we've taken basically the hardest, in my opinion, the hardest game that humans know how to play, which is Starcraft, or at least know how to play well, and we do research in that area in the hopes that the research that we're doing here can also be applied to other problems which exist in the real world. So, we have the MUN AI and Games Lab. It's a real lab that exists at MUN in the computer science department, which is about 1.5 years now that we've actually had that room. So someone retired, and space at MUN doesn't grow on trees, and we were lucky enough to sort of swoop in and get that space. So a lot of cool money has gone into the lab. Well, a lot of cool people are funding the money for that. So we have Memorial University, obviously, we're there, we're in their buildings, they give us money. ACOA has given us money, which is awesome, along with InnovateNL, so they sort of partnered up for this Memorial AI Lab project that I have going right now. It's a 3-year project, we're currently about half of the way through, and that's funding a lot of the hardware and the master's student salaries for this project. Also, we've gotten money from Facebook AI research and from Google DeepMind as well for some of the hardware for the Starcraft AI competition and for the hardware for our, graphics cards and stuff like that for deep learning. So this is a picture from last year from our AI lab indie band that we're forming. So this is 4 of our students. This is Rory, Caroline, Rick, and Lucas. We have 2 other students now, Rob and Sean, who are there but weren't there at the time of the picture. Yeah, this was taken in the lab. So what are the current research projects that we're working on? So first, this isn't necessarily like a research project where we're doing active research, but it's really worth mentioning. So these are the Starcraft AI competition that I've been talking about. So there's 3 major international Starcraft AI competitions where literally the best AI in the world is on display. I'm not joking about that, it's actually the best AI in the world. And so there's one competition which is associated with the AI and Interactive Digital Entertainment Conference, the AID conference. That's the one, it's the longest running one and the one that I currently organize and run at MUN. There's the Computational Intelligence in Games Conference competition. That is in a different place every year. And then there's the Student Starcraft AI Tournament, which is an online-only competition that's run by Michael Serticki, and that's in Europe. I can't remember the exact university where that's run. From my count, there's been 19 different countries that have submitted to these competitions. Here's like the more popular countries that have submitted over the years. And lots of thanks to all the people who've been involved with this, because it's not easy to sort of get all these submissions and run these competitions every year. So lots of funding from different people for hardware, Blizzard has officially given us their blessing after like 10 years of sort of flying under the radar, sort of trying not to make them mad by using their game engine for things it wasn't supposed to be used for. And last year, the competition was actually won by a team from Samsung. And so last year, there was a team from Facebook that entered, and there was a team from Samsung, and SIDA stands for Samsung something or other, I can't remember. Samsung AI something something. But their bot it was just amazing. It was really, really good. Probably not as good as the recent Alpha Star bot, but it was awesome to see what can happen when a company with that sort of funding puts a bunch of professional developers on a project like this. So that's really cool. We're running the competition again this year in September. The submissions are open. If you're interested in maybe entering or being involved in that, just let me know. One of the other, so one of my students, Caroline, has been working on autonomous robotics and using reinforcement learning, which is a type of machine learning, to do automatic pattern formation. And so picture you're on a construction site or something, and you have a bunch of materials that you want moved into a pile in a specific configuration, but you don't want to have to do that on your own. And making one robot to do that, a single robot that could do everything, might be really, really expensive. And so what we thought, and Dr. Vardy in the computer science department, who is a specialist in robotics, we're interested in swarm robotics. So intelligent behaviors that come out of using tons of small, unintelligent robots. So if you have dozens of robots or hundreds of robots that are individually not very smart, they can actually produce really smart behaviors. So in order to do this, sorry, this is flickering at a weird rate. So we wrote a physics simulator because all of the robotics physics simulators that were out there weren't fast enough to really do this sort of real-time reinforcement learning. So we had to write our own. It was based on this previous simulator called Waggle, which was written in JavaScript. That's why it was so slow. And we rewrote it in C++, so I called it Swaggle. And this is what it is. And you can do all sorts of things with it. And you can notice that if you arrange things in a certain way, it could actually do particle simulations or fluid simulations. So it's really cool what you can do with just spheres and circles. So here's the outcome of one of our latest bits of research. We have, this is fast forwarded a lot. There's a blue robot moving around, and these red dots are we call them pucks. They're stationary objects which move when the robot bumps into them. And so we just tell the robot whether or not its last action made the pucks go into a configuration which is closer to or further away from this circle formation that we want the pucks to be in. And just based on that feedback of that was good or that was bad, the reinforcement learning algorithm actually learns to cluster the pucks on its own into these circle formations. And so these formations are given in a specific format, and we just give it this, it's called a reward function. The reward function is negative if it's pushing things in the wrong direction, or positive if it's pushing things in the right direction, and it just learns to cluster things automatically. And what you just saw was in real time. It's actually, this is about 100 times slower than how fast it actually learns. And so within seconds, you've got these robots learning really complex behaviors. And this scales up to any number of robots. So if you put 20 robots in there, they'll learn to act collectively and do these sorts of cool things. So that's one thing we recently did. Another thing is real-time strategy game combat algorithms. So teaching robots to kill each other. That can't ever work out poorly, right? So real-time strategy games, the combat in those games is really, really complex. And for a number of years, I've been trying to write algorithms to, like I said, make robots kill each other the best. So we wrote this other simulator. This is called Starcraft, which is, since we don't have access to the source code of a lot of these games, we spend a lot of time writing simulators. And so this is this visualization of that simulator in potato quality, PowerPoint, which shows dragoons killing other dragoons in StarCraft. But recently, Blizzard and Blizzard and DeepMind have released this machine learning, Python machine learning, it's a machine learning package for Starcraft 2 written in Python and TensorFlow, which sort of breaks down the game of Starcraft 2 into these different feature layers. So over here you can see all these different feature layers. One is the map, another is the resources, another is the units, another is the workers, another is the gas, etc. And so we can do learning really effectively on these different feature layers. And so one of my students, Richard Kelly, is currently working on real-time strategy game combat using deep reinforcement learning with this PySC2 learning framework. So there's another game that we're working on AI for, which is called Prismotta, which is a strategy card game online. It's sort of like a hybrid, picture like Hearthstone meets StarCraft. It's a really interesting game. And so this game was made by Lunark Studios out of Waterloo, Ontario. And while I was doing my PhD, I worked with them on this game. I created the AI system for the game. And the AI system for the game currently uses heuristic search. And we said, maybe we could combine machine learning with this heuristic search in order to produce a stronger AI. And so I'm going to really quickly go through this because I want to show a video at the end. But essentially, when you're doing AI for actual video games, you care about a lot more things than just how strong the AI is. It has to be modular. It has to still work when you balance or patch the game with different properties. You're actually working to make the player have fun, not just create like the deep blue of the particular game. So we combine search and learning. We use deep neural networks and alpha beta search to create the new best AI for this game, essentially. That's what we just submitted a paper at 3:30 this morning to a conference about this, so hopefully that gets accepted. But in the future, I want to go more in this direction of AI for game design and development. So, you have these tools like Unity. We want to build AI into these tools to help designers make games. Not just play games, but make games. So for example, I built a puzzle solver for Prismotta. So if you put it into a particular situation, you might want to know, could one person possibly win from this situation? So games like Hearthstone have these sort of like puzzles, but the designer, maybe they don't want to sit there for 2 weeks trying to solve the puzzle. So let's have the AI solve the puzzle, and then I can make little tweaks. And so these tools, this was actually used by the designers of the game to make some of the levels in the game. Also, we want to look more into procedural content generation, so like level generation, enemy generation in video games that could help you in real time do stuff like this. Also, at MUN, we have courses now that are completely devoted to video games and AI and video game AI. It's really awesome. So here are just, I say just some of the courses, but the courses that are being offered currently. So there's Computer Science 3200, this is the Intro to AI course that I teach. There's 3201, which is nature-inspired computing, which talks about things like evolutionary algorithms, neural networks, etc. There's Intro to Machine Learning course, so if you're interested in machine learning, Lourdes teaches that course. She's amazing. She's the machine learning expert at MUN. There's 4300, which is Intro Game Programming. I see at least a couple of people who have taken that course in this room. 4303, which is a new course which will be offered in the winter, which is AI in computer games. So it'll be specifically for AI in computer games. And then there is the Comp 4770, which is a team project sort of software engineering course that people take at the end of their BSc at MUN. But since I've been teaching that course, I've kind of turned it into a video game programming course. So I just wanted to show the last class we had, some of the projects were absolutely amazing. So in that course, I teach students how to design and build a game from the ground up. So the trailers that you're about to see were written in HTML, Canvas, and JavaScript from scratch. Okay, there's no game engine behind any of this. And also, both games created their own assets and animations and sound. Sometimes they borrowed some sound effects, but like the music and stuff, they made it all. So I just wanted to show 2 of the trailers because I had them make trailers for their games just to sort of see what sort of game development is going on at MUN. So I hope the sound works. also make their own level editors for the games. And this is all done from scratch in 3.5 months. So it's really cool what they're able to do with one of the cool games that was made, and I want to show one more trailer which I found absolutely hilarious, which had sort of a Newfoundland themed game by one of the groups in the course.
Canada Post workers have been taking part in rotating strikes across the country this past month.
Someone actually drove around downtown for the game trailer, which was awesome.
The Canada Post is warning if there isn't a deal by tonight, holiday deliveries could be in jeopardy. Holiday deliveries could be in jeopardy. Holiday deliveries could be in jeopardy.
You notice the pineapple crush bottles and the screech. The last boss of the game is a giant seal, so that's why that was there. Yeah, so really cool stuff. There were 8 games, but obviously I can't show all the trailers. I said I was going to put them all on my website before this, but I haven't, but look for them there. And so that's kind of just a recap of what we're doing in the MUN Computer Science Department in terms of AI and games, and it's really cool. And if you want to talk about doing a master's or game design or game programming especially, that's what I'm into, just let me know. Thanks.